Back to the prep assignment, math from the void, math smacking you out of nowhere. Today we're really going to continue to challenge you quite a bit in your understanding of lines. Last time we talked about lines using the slope-intercept equation. Today we're going to talk about lines using this standard form equation. And then later we're also going to talk about the equation of a line in point slope form, along with a couple of things about circles. So we're going to remind you lightly about circles and how we can work with them. So first of all, let me mention something about the standard form of line. The standard form equation of a line. So that's going to look something like, let's say, ax plus by equals, let's put it in bold, c. That is the standard form equation of a line. And it's almost what we have here. I won't even read the question yet, but I'm just showing you the objects that are involved, which is the standard form equation of a line. Now, this is most convenient for actually graphing lines. It makes it really easy for you to graph a line. And I'll actually include that in the note. Is a convenient form for graphing the line. By using the x and y intercepts. Okay. There we go. So how do we find x and y intercepts? Well, you need to remember this. So write this down if you don't already have it written down somewhere. And even if you do have it written down somewhere, it's so important. You should probably write it down again. Because if it's not on the top of your head, it needs to be. In order to find x and y intercepts, we have to make the other variable 0. So it's a very simple process. To find the x-intercept, set y equals 0. To get the y-intercept, set x equals 0. Really simple. And that's why it's such a convenient format, because if we make the x or the y 0, you'll notice that it's just going to completely obliterate whatever's there. Like if I set x equal to 0, then I just have by equals to c, and I can really easily find the y-intercept. Or if I make the y 0, this goes away, and I do the same thing. I just divide by a, and I have my x-intercept. That's a really convenient way to graph this, and to find like some really nice coordinate points. Now, is that going to be particularly useful? Most likely. So let's see what the question is actually asking us. Find the area. That is red alert. Red alert, red alert. The area. We're going to need the area formula of the region. It doesn't say what shape it is. We're going to have to figure out what shape it is. You can expect it's pretty much going to be like some parallelogram or some kind of rectangle or some kind of triangle for the most part. It's usually not going to be like a circular equation. Bounded by the x-axis. Okay, so these are some important boundaries of the region. We have the x-axis, which is just like the horizontal axis, and the line L1. So this is one of the boundaries, and also the line L2. So this is one of the boundaries. In fact, I think I'll use a different color for that one, and that way when we're sketching the lines out, there's no confusion on which line is which. All right, well, let's draw a grid, and let's also get these in the correct form. So we're going to have, let's move the 1 over. So this is going to be 2x minus 3y equals a negative 1. Okay, that's our blue line. And then this one's going to be 2x minus y equals positive 9. Okay, perfect. So let's go ahead and find our x and y intercepts before I even draw my grid. That way I know, how big I need to put it, and if I need to have more showing on the right or on the left, I want to use my space wisely. So let's find the x-intercept. I'm just going to put x dot dot. And if I make y equal to 0, then I get 2x equals negative 1, which means x equals negative 1/2. So my x-intercept is negative 1/2, comma 0. That's a point on the line, and it's also on the x-axis. Now, if we find our y-intercept, do the same thing pretty much. We're going to have negative 3y equals to negative 1. So therefore, y equals positive 1/3. Okay, so we'll have 0, comma 1/3. That is your y-intercept. All right, so as you can see, we don't really need to scale the graph that much. You get what I'm saying? We don't have to make it go out to 5 because this only goes to 1/2 and 1/3. Now let's see if that's the case for this other one. If we find the x-intercept, we make the y equal to 0, so we get 2x equals 9. And therefore x equals 9 over 2, or, that's just 4.5. So our x-intercept for the second line is 4.5 comma 0. And our y-intercept is going to be negative y equals 9. So then y equals negative 9. This is a pretty big number. So we are going to have to go pretty far out to the right, because this is to the right. And we're going to have to go pretty far down, because negative 9 on the y is pretty far down. Okay, that gives me an idea of where we're actually drawing this thing. So negative 1/2 and positive 1/3, those aren't very far, but we're going to definitely need some space from the second line. So maybe I'll do something like that. You get what I'm saying? So negative 9 can be like down here. Let's just put it like way down here. Let's put 4.5. 4.5 will be somewhere around right here. So we can go ahead and draw this second line through the 2 points that it has as the intercepts. Remember that the x-axis is also a boundary. And then we can use these x and y intercepts here in the, what color did we have? Was that the right color? Blue? That's close enough. Negative 1/2, 0, and positive 1/3 on the y. So that's going to literally be like, what the heck? 1/2. One-third will be a little bit less than that. Seems not completely reasonable that those will cross, but let's go ahead and check that out. Yeah, I guess they will eventually cross since their slopes are not the same. Okay, and so since the boundary is the x-axis, that's going to be right here, and you can see that it makes a kind of like a triangle. We can see that the base is this distance, and the height is going to be whatever the y value is where they're crossing. So even though this line segment that I'm drawing is not in the triangle, it's still the height of the triangle. So we can use the area formula for a triangle to find that, but we have to find out what is this base. The base length is pretty easy because we're going from negative 1/2 to 4.5, so 9/2. So that's going to be a total of 5, the base length. Okay, now how do we find the height, though? We have to find where these two lines cross. We saw this sort of thing last time when we have two lines that are intersecting. We can basically set their y values equal to each other, right? So we're going to set the y values equal to each other. In order to do that, we need to put this in a more appropriate format. So let's take this equation here. Go ahead and work with it until you solve for the y value. That's going to give us y equals, you'll notice that I'm going to start going a little bit faster because you need to keep pace. This is going to be y equals 2/3 x plus 1/3. That is the equation in slope-intercept form for L1. Okay, now let's look at L2 and we'll set it equal. This one's actually pretty nice to turn into slope-intercept form. If you solve for the y, fiddle with it a little bit. You can move stuff to one side or you can move stuff to the other side and divide by a negative. Either way is totally fine. So you'll end up with y equals 2x minus 9. And this is our L2. So let's find out where they meet, which is where they are equal. That means we want 2x minus 9 to be equal to, 2/3. 2/3 x minus 1/3. Is that right? Do I have that right? Yes. Wait. Do I have that right? No, that should be plus. Okay, so let's bust the fractions. Let's get rid of the fractions by multiplying everything by 2 on both sides. So on the left side, that's going to become 6x minus 27. And on the right side, that's going to become 2x plus 1. We always subtract onto the side where there is more x's. So there are more x's on the left, so we're going to move all the x's from the right side to the left. And then, of course, that means we're going to add 27. And we get 4x equals 28, which means x equals 7. Now, because I solved for y in both of the equations, it's not going to allow me to find the y right away. It's going to allow me to find the x right away. You'll see that the equation I just wrote has x's. But you can easily find the y value by just plugging that x in to either one of the lines. So I might as well just plug it into the easier one, which is 2x minus 9. You could plug it into either one, 2x minus 9, or this 2/3 x plus 1/3, but there's just no need to use the one with fractions. So y is going to be equal to 2 times 7 minus 9, which is 5. So that gives us the height of this triangle. All right, so we can just use carry out the area formula. That's going to be I guess I'll write it over here. The area is going to be 1/2 base times height. So 1/2 5 times 5. And so we're going to get 25 over 2, or if you want to call it 12.5, that's fine. 12.5 units squared. So if it were a base of 5 centimeters or 5 inches or 5 meters or 5 feet or whatever, it would just be that same unit squared. And that is the area. Okay, now let's move on to the circle. The circle requires you to consider the equation for a circle. This is the general equation for a circle. And if you don't have this down, I want you to have this down. Write it down. X minus h squared plus y minus k squared is equal to r squared. R is the length of the radius. And h and k, what are those? Do you remember? H and k, those are the coordinates for the center. I guess I'll put it in the same color so it's matching. Otherwise, it's like, why are they in a different color? I wrote those because in a different color in these equations because they're subject to change depending on what actual circle you're looking at. Okay, so what do they give us about this circle? Tell us the endpoints of the diameter. Okay, so we're going to need to consider that. They give us endpoints of a diameter of a circle. Here they are. Write the equation. Okay, so we already pretty much have the equation template set up of the circle. So what does that mean? That means we need to be able to find the center, and we need to be able to find the radius, which is just r. How are we going to do that? Especially considering what they gave us. So let's remind ourselves, what did they give us? They gave us endpoints of a diameter. You got to know what a diameter is. Diameter goes across the circle. So if I have a circle, it's not the greatest circle, but if I have a circle, the diameter will always be the line that goes across the circle and therefore cuts through the center. So a diameter would be like, that is an example of a diameter. There are multiple diameters on a circle because depending where you start from, you can start anywhere on the circle. So we have like an infinite number of diameters. Another diameter from here would go straight across. Wow, that's pretty bad. We'll go straight across and hit maybe like that spot, for example. That would be the same length. Okay, what's special about the endpoints of a diameter? Well, the diameter, you might remember, is twice the length of the radius. So the radius is the distance from the center to the edge of the circle. And therefore, if I have this radius going to the edge of the circle, and then in the opposite direction, I do the same. Then that's 2 radius lengths, and that's called a diameter length. So if we're given 2 endpoints, which we are, we can find out the distance between them. And then we can even find the center location because we can find the midpoint. So the center is the midpoint of every single diameter on the circle. So if we're given 2 endpoints, we're going to need the midpoint, and then we're going to need the distance, which we don't have to find the distance between the endpoints. We might as well just find the distance between the center, the midpoint, and one of the endpoints. So once we calculate the midpoint, which is the center location, then we can just use that point and one of the endpoints, you get to take your pick, and we can find what the radius length is using the distance formula. Okay? So first let's find the midpoint. Remember how we find the midpoint. If we just worked on these kinds of things on a previous video, you cannot forget these things. I don't know how else to say it. It's very important that you remember them. I guess that's how I should say it. It's like very important that you remember them. If I just say it like that though, it's almost like I'm only hinting. I'm only making a slight recommendation. No, like it is required for you. I'm not gonna go crazy Russian math with it, but like it's required that you do not forget. I had a Russian math teacher that would be like, "You do not forget." It's literally what he sounded like. He goes, "You forget, don't forget. You do not forget." I was like, all right, I guess I can't forget anything. No pressure though, guys. Okay, so the midpoint. How do we find the midpoint? You add the x values. To find the middle of the x values, you add them and then divide by 2. And then for the y values, you add the y values together and divide by 2. The same as finding an average. So we have negative 2 on 2. That's negative 1. And positive 6 on 2. That is 3. So our center location, our h and k, we just found. And now we can find the radius because we can take one of these points and find the distance between them. I think I'll just go with these 2 points, the center and one of the endpoints. Now, if you do want to do it between the endpoints, that is fine. But just know that you'll have to cut this distance in half at the end because the diameter does not give us the radius. The diameter gives us 2 of the radius lengths because it goes all the way across the circle. The radius that we want is just from the center to the edge of the circle. All right, let's use the distance formula. Distance formula is pretty easy. It's just the x minus x. So we can do 1 minus negative 1, which is positive 2 squared, plus, now we do 3 minus 1, which is also positive 2, and squared. I guess instead of calling this d, it's d for distance, but it seems like it's diameter. I might as well just put r. So r equals the square root of 4 plus 4 is 8, and therefore the r squared is equal to 8. Now, why did I find the r squared? Why did I go further? Because in the equation, remember our general equation, yes, we do want to know what the r is, but in the equation, we actually put the r squared, right? Excuse me. Sorry if that just ruined your ears. A little sneeze. Maybe not such a little sneeze. So let's write the equation with our information now. So the center location, that's going to be negative 1, comma 3. So this will give us x plus 1 squared plus y minus 3 squared equals, if you really want to, you could put square root of 8 squared so that the radius is very, very clear. But also if you want to, you can just put 8. Okay, so some new stuff about circles coming up next. Write the equation. So they're already telling us what to do. Red alert here. Write the equation of the tangent, which is a line. We'll talk about that in a moment. Tangent to the circle. Ooh, that's also an entire concept in itself. A tangent to the circle. So they gave us the equation of the circle. If we were interested in, we can draw the circle. Notice that the r squared is very weird. So the r, the radius length, is the square root of 61. That's not a very nice number, so hopefully we don't have to do too much with the r. At the point 8, -8, put your answer in point slope form. Okay, so I'm going to include that in the red alert. Because even if you didn't know that the tangent was a line, which you should, but even if you didn't know that, point slope form, this is the form, that's the name of a line equation, the form of a certain type of line. Now let's talk about this tangent to the circle business. Before we even consider the exact equation, just take a circle. What does tangent mean? You might remember sine, cosine, tangent. We're not necessarily going there. Wow, that is a pretty bad circle. In fact, it'd be funny if I just used if I use this circle as like a template. It came out a little better because of that. Okay, so here's a circle thingy. What is a tangent? A tangent is when it is meeting the circle, kind of sitting on it. It's not going through it like this. That's not a tangent. A tangent just sits on it. I didn't quite draw that perfectly, but I'll move it so that it looks nice. Something like that. See how it's just kind of sitting on it? So it hits it at one point, and it has the exact same slope at that point as well. It has the exact same slope as that point. And there are many tangents to the circle, right? I can draw a tangent here, or I can draw a tangent here, or something like that, right? But there's one important fact about the tangent to a circle. Everywhere there's a tangent. Let's see, we'll make this a little smaller. Whenever a line is tangent to a circle, it is sharing. That's kind of an important thing I didn't consider at first. I'll underline it as well. Sharing a point with the circle, and its slope, or I should say, and it is perpendicular. We looked at that word earlier in the last video. It's perpendicular to the radius at that point. So let me kind of try to illustrate what I mean here. First, we're saying that if a line is tangent, like these lines are tangent, it shares a point with the circle. So the equation of these lines would have this point, where this line would have this exact point, and this line would have this exact point from the circle. We were given one of these points, so now it's starting to make a little more sense. We're given a point 8, -8. So they're basically telling us, hey, this point is on the circle. It's on this circle, and you can plug it in to check that if you wanted to. You could plug in x equals 8, and you could plug in y equals, oops, don't want to drag that. You can plug in x equals 8, and you can plug in y equals -8, and you can see that the math works. You'll get, when you do all that stuff, it equals to 61. So it's on the circle. That means it's also on our tangent line. So we're going to need to use this, and it makes sense that we're going to have to use it. They gave us the point for a reason. We're going to have to use this for the line. But what else is really important about lines? The slope. We're told that the tangent line, this line that's tangent, is not only sharing a point, it is perpendicular to the radius at that point. So let's take a look at the radius. Remember, the radius is the distance from the center to the circle. Or I guess I should say it's a line segment from the center to any point on the circle. So for example, there's a radius. It goes straight out from the circle, from the center of the circle to the edge of the circle. And what do you notice about the tangent line there? It is perpendicular. What about these other tangent lines? It is perpendicular to the radius at that point. See, like I said, there are lots of different radius segments. But wherever you have a tangent, if you draw the radius out to that point of tangency, then it's perpendicular. So what can we do here? We can find the slope we can find the slope of the radius, the one that goes from the center to the given point, 8, negative 8. And then we can take the opposite reciprocal, and that'll give us the perpendicular slope, which will give us the perpendicular slope. It'll give us the perpendicular slope, which is the slope of the tangent line. Okay. Last thing to talk about before we finally jump into the calculations. I'm really just sort of game planning. I want you to understand that really most of what I do really quickly, the reason why I answer questions really quickly and I take my time when I'm doing these instructional videos is because you got to formulate a game plan. I'm really good at doing that as I go. But if I want to break it down, it's safer. And how I learned it myself is I would have a game plan and just, make notes on your question. Make sure you understand everything that you're being required to do. Put the red stuff that's important, underline the important stuff in red. Maybe circle related ideas like tangent to the circle. What's the circle equation? Now, if we didn't just do a circle problem, you would have to recall the circle equation. So, don't kid yourself. Don't lie to yourself and be like, oh yeah, I would have been totally fine with this if I were given this randomly. Maybe you wouldn't have. Maybe you didn't memorize the equation of a circle. So go back and memorize it. If you had to look at it again before you did the next problem, you probably don't have it memorized well enough. So just stare at it, 5, 6 times. Just do a flashcard thing like this. Like, look at it. Okay. And then look at it again. And then, okay. You get what I'm saying? Seems silly, but trust me, you're learning from somebody who's mastered this process. And I'm giving you my honest advice that anybody can use. So point slope form. Let's talk about the point slope form. We talked about general or standard form of a line. Now we're talking point slope form. There are 3 forms of the line: the slope intercept, the point slope, and the standard form. So we've already talked about one of them yesterday. Well, maybe it was yesterday when you did it. It wasn't yesterday when I recorded it, but in the previous video. And then we did one of them earlier in this video, and now we're doing the third one here. So the format in point slope form, you might understand from the name that it requires you to have a point and it requires you to have a slope. I know, earth-shattering, right? It's almost as if it were named intentionally. Well, it was named intentionally. So the point that we're talking about is a point through the line, and the coordinates of that point are x1, y1. And then m just stands for the slope. If you can find that information, you're good to go. And we already have some of the information. We have the point. So this is going to be y, I believe y plus 8, because the point is 8 comma negative 8. So y minus negative 8, I guess I'll write it in the true form first, equals m, which we don't know. It's going to take a little work to find that slope. We discussed the plan for that. And then times x minus 8. So let's go over the plan. The plan is to find the slope of the radius. I don't even know if that's pointing in the correct direction. It doesn't matter. We're just going to find the slope between the center and the given endpoint. And then we're going to find the opposite reciprocal of that. So what is our center? Between the center point. What's the center point? Now we can use the equation. This is x minus 2, which means 2 is the x value of the center, and negative 3 is the value, the y value of the center. Between 2, negative 3, and 8, negative 8, we want to find the slope between those 2 points. That's going to give us the radius line slope, the slope of the radius line. The slope of our tangent line is perpendicular to the slope of the radius line. So let's just find the slope really quickly. I'm not going to put m, I'm going to put slope, not confuse you with m over here in our tangent line. So the slope is going to be, what's the equation? Again, if you don't have this memorized already, you need to go back and watch the other video as many times as it takes for you to remember this. In fact, this is like an Algebra 1 thing, so if you can't remember this, it's pretty unsettling. Okay, so let's do this. Negative 8 minus negative 3 over 8 minus 2. So we have negative 8 plus 3, which is negative 5, over 6. And that doesn't reduce at all. But our perpendicular slope is therefore going to be positive, and it's going to be 6 over 5. Okay, so that took some work, but it really mostly took thinking and planning. And then we can go to our equation, make this look nicer. This is going to become y plus 8 equals positive 6 over 5, x minus 8. And that is the equation of our line. Right on. Let's get moving. That's pretty much all you'll need to know about circles and stuff like that, going into calculus, I would say. And the area formula, which we didn't discuss, but that'll come back to you pretty fast. Some of the geometric formulas you'll need to review before you begin certain sections of calculus. But just of basic shapes, you don't need to find, unless your teacher's a little bit more applied, a little bit tougher, you don't really need to remember like how to find the area of like a hexagon or things like that. It's mostly like squares, rectangles, trapezoids, triangles, circles, that kind of thing. Okay, let's find all ordered pairs, x, y, which satisfy the system of equations. Satisfying a system of equations. Solving, in other words, a system of equations. Your answer will be in terms of t and w. So what does this mean? This is a very important thing to take note of. If it says it really doesn't have to say that, but if it is nice enough to tell you that your answer is going to be in terms of something, in terms of basically means treat them as regular numbers, which we call constants, regular unknown numbers. The reason why it's a constant and not a variable is because we're not allowing this number t or this number w to be many different things. We're allowing x and y to be many different things, ordered pairs of these variables. T and w are just represent a single value. We don't know what value exactly. Maybe it's 3, maybe it's 1, but it's a strict constant value. It's not changing. So basically treat them as regular unknown numbers, like -2 or 3. If you have to subtract them around, if you have to divide them, if you have to multiply them, just treat them like normal. But what it also means, you should expect to have those terms in your answer at the end, which basically means like, do not try to solve for them. Unless it says solve for the value of t and w, and then it gives you some other information. But if it doesn't tell you to do that, don't worry about doing it, really. Okay, so how do we solve a system of equations? Well, part of the system of equations, it doesn't really look like they're in the format that we typically see. Normally we have this thing moved over. So let's move that over first. We're going to say 3x minus y equals positive 5t. And we're going to say x minus 2y equals negative 5w. Okay, so the best method, in my opinion, when you're able to use it is the elimination method. So we're going to do the elimination method. If you don't know what the elimination method is, here's a reminder. That's quite a bit. To manipulate an equation in order to set up a variable, in order to line up variable expressions which cancel each other. Yeah, that's fine. What do I mean by that? Well, let's look at these equations. We can add the equations together. We can add these equations. Like we can do the left side plus the left side is equal to the right side plus the right side. Makes sense because the left and right sides of each is balanced. So if this is like 100 and this is 100, I can add those to either side here. But we want to add them together once they're in a position to cancel each other out. So what I want is like the x's to cancel each other out, or maybe the y's to cancel each other out. So in this case, I see that I can multiply this equation by anything, and it will multiply the x by something. So I could multiply the bottom equation like by -3, and I would have -3x, which can cancel with the 3x, you understand? But the smallest number that I can use here is I can use this -y times -2. So I'm going to multiply the entire top equation by -2, and I'm going to write it underneath this second equation. So here we have -6x plus 2y equals -10t. Okay, great. And now I'm able to add these equations together. You add the left sides. So that's going to give me -5x, and then these cancel, equals -5w minus 10t. Now I cannot combine them together. I can't put like 15tw or something. I don't know what those numbers are, so they don't necessarily combine one to one. Let's divide everything by -5. And that'll do it, everybody. Well, for finding x anyways. X is going to be equal to positive w plus 2t, because I'm dividing each of these by -5. Okay, there's my x value. Now I need to use that in order to find the y value. So how am I going to do it? Well, I think I'll use the second equation. Yeah, I think I'll use the second equation. It says x minus 2y equals -5w. I guess I could have just included the negative. But since I know what x is, I can go ahead and substitute that. So now I know that w plus 2t minus 2y equals -5w. And what am I solving for here? I'm just solving for y. Remember how I said don't be alarmed with the w's and t's flying around. You should expect to have these in your answer at the end. Do not try to solve for w's and t's. You want to isolate the y. And that's what makes this problem a little bit challenging, is the other letters kind of just distract you, but you need to stay focused. What are we solving for in this step? We're solving for y. That's laser focus. We're plugging in other things. We're plugging in x equals this and all that stuff, but we're laser focused to find the value of y. Okay, now let's move everything over. We can subtract w, we can subtract 2t, all the way over there. And now we have -2y equals minus 6w minus 2t. And then we can divide everything by -2. And that'll leave us with y equals 3w plus t. And so now we have the solutions, x and y, of the system. So we say that x and y are equal to w plus 2t, 3w plus t. And what that means here is that you can pick any w and any t value that you like, and they would be solutions. For example, if we have w equals 0 and t equals 3 or something, you just pick random numbers. This should work. That means that 0 plus 6, comma 0 plus 3, that would be a solution. Or if you want w to be -5 and t to be -7, that would give you another different solution. This sort of gives you like a formula for your solutions, because there are many of them. There's not just one solution. That's what this means. We have some constant numbers in there. This would be like negative, what would that be, -19? Yeah, be like -19, comma -22. That is also a solution. So instead of writing all of those out, because there are an infinite number of them, we can just describe it in terms of w and t, and that is our solution. Okay, you made it through. Congratulations. Well, if that was not a wake-up call on how much you need to remember from the previous video, let me tell you, there are going to be several wake-up calls in this video series. So keep yourself sharp, keep studying outside of these as well. And next time we're going to talk about a word problem. See you then.